Okay, so picking it up in Chapter 2 with TCP ports, the TCP packet, as you noticed in that header, had a couple of fields with that contain the bits. So most networks use TCP/IP as the network protocol, right? And as we said, it was a set of rules for communication between devices, and the rules of TCP/IP require information to be split into these packets that contain both a segment of the data to be transferred and the address to where the data is to be sent. So TCP allows for this transmission of information actually in both directions at the same time, which is great. This means that the computer systems that communicate over TCP can send and receive data at the same time, like a phone call, really, right? And so the protocol uses segments, or we call them packets, that's a segment, as the basic unit of data transmission. Now the port is not a physical place, it's a logical address, right, that the TCP is going to. And it identifies a running service. So if I want my clients, my employees, to have access to the internet, I'm going to give them access to port 80, that logical port where HTTP traffic is allowed. So it helps you stop or disable unneeded services, right? If you're having a denial of service attack and it's on one computer, you can unplug that computer from the port, right? Close the port. If you're having a denial of service on multiple computers, you can terminate transmission across all ports that it runs on, right? You can segregate it, isolate it. So in TCP/IP and UDP networks, remember one is connectionless. That's TCP, and the UDP is connectionless, and TCP has ensures the connection, right? A port is an endpoint to that logical connection on the way to the client program, which specifies these rules, right? So here's a rule for you as a security professional, as a security tester. The more running services means the more ports you have open, and the more ports you have open to attack. So you really want to close any ports that aren't used. If your computer isn't meant to get access to the internet, you want to close port 80, the logical port to that computer. You do not want access. There are lots of other ports that do lots of different things. The following slides describe them. The first 1,000 or so are considered well known. IANA, the Internet Assigned Numbers Authority, they have actually assigned these ports, but there are thousands of others that are not assigned by IANA. So if port 20 and 21, for example, is how we transfer files between operating systems, right? It was the standard. Today, it's used today less so than ever due to we're moving files via HTTP. Right? Okay, and here's how we might configure a TCP port for UDP. So for example, the FTP port service uses ports 20 and 21, and the file transfer protocol does for moving and copying large files, right? Okay. It's kind of a summary, well covered in the book. Here are some more TCP ports. Port 25 is for mail transfer, right? The email servers are actually listening on this port for mail. The domain name service I mentioned, you want to avoid man-in-the-middle attack, which could give them access to your DNS cache, which would then give them access to your IP addresses. So port 53 is very important to secure, right? It's used to connect the websites to the URLs. okay, instead of using an IP address. In the early days of computing, we'd load the IP address, where today we just type in Google and hit enter, and it goes to this DNS service, looks up the actual IP address, and then plugs that in for you. It's quite a good service, but it's easy to get into and be redirected by a hacker. Port 69, Trivial File Transfer Protocol. Port 80, I've already talked about. That's HTTP. That's your web server. Port 443 is a secure hypertext transfer protocol. So you'd want to use HTTPS or port 443 for your banking services, things that you want to ensure are secured. If you want to retrieve your email, you would use POP3 or Post Office Protocol. Other ports listed here. NetBIOS is the transition between layers 4 TCP/IP and layer 5, the session, right? It's the basic input-output to the network, all right? It establishes your session. Okay, another one is IMAP4 is port 143 and used for retrieving email also. But POP3 is more common in my experience. Okay, remember besides TCP, which was transportation oriented, you could confirm the arrival of the packet. Well, then we also have UDP in this layer 4. UDP is fast, but it's unreliable. We don't know that it got there. We're not tracking it. It's very useful. It reduces latency on computers, and so it speeds up the traffic. When your computers synchronize with the timing, it's using UDP, right? So UDP can be valuable. So for your risk register, for example, I get concerned with a couple of risks. One I mentioned is man-in-the-middle attack. This type of attack is when the hacker gets on our network and injects themselves into our conversations. And they do that by manipulating the packet information, especially the header information. Well, one type way of doing that is called spoofing. Spoofing is something you'd want to list in your risk register, I think. Spoofing would be one of those things that you want to look for. This is the form of header manipulation, right? Where you're spoofing the source port, specifically under spoofing. So you might want to add that to the risk register. I mentioned, in addition, a man-in-the-middle attack could manipulate these packets, and they could do ARP or DNS poisoning. And by poisoning them, they could redirect the packet to the wrong IP address, giving the hacker great information or ability to get into the conversation. Now, if you are unaware of any of the meanings of these, I would say write them down, go back and look them up. But I think we've had enough background to be pretty good at that. Now, the internet layer is going to, so that layer 3, it's going to route. So TCP is layer 4, and I said layer 4 and layer 3 work together. TCP or UDP is layer 4. Layer 3 is the IP layer. This is the routers. The routers route the packets to the destination address, right? Using a logical IP address we call an IP address, right? ICMP is also part of layer 3, and this sends messages related to the network operations. So it's frankly goes like this. It's pretty easy to remember. Since routers are operating on layer 3, the IP address, it takes the IP address and routes it, the source to the destination, right? It figures out the best path. Well, ICMP is a message, and its role is to reduce the rate of datagram transmission by ensuring that they're getting where they need to. It will actually redirect messages. ICMP will send a redirect message, right? Which is sent by the router if it receives a datagram that should have been sent by a better route, by a different route. So the message contains the address to which the source should direct future datagrams in, right? Here's another item that you might add to your risk register. When we're troubleshooting connections, we have the ping command. And ping is a computer network admin utility that is used to test the reachability of the host of an IP address, right? So we send out this ping, right? And ping operates by sending out this ICMP echo, it's called. This echo, it's ping, right? And we request packets at the target to send an echo reply. And that's how we know the route is good, right? It's a ping packet using ICMP echo and echo reply. And here are some of the codes that would go with it. ICMP echo would be code 0. Code 8 would be the echo reply. Here are other echo ICMP codes that you should be aware of. Don't memorize them, just glance over them, be familiar. ICMP 0 and 8 are really the two most important. So with that then, at this layer 3, we are doing IP addressing. And an IP address consists of 4 bytes divided into 2 areas. This 4-byte address is divided into a network address and a host address, right? So the IP address is, let me move the slide just a little bit here. So the IP address looks like this. It's this 4 bytes we call octets, and they're separated by decimals. You see octet, 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 and octet. And so remember, these are just bits. They're yes or no, on, off, up, down, right? That's the only choice. And so notice that this IP address with the 4 bytes, which have the various bits, can be translated into the common IP address that we see, right? So this is called an octet. There are 4 octets in an IP address. And each octet has 8 bits. You see the 8 in green, 8 in yellow, 8 in red. So 8 bits makes up a byte, which is called an octet. And 4 octets make up the IP address. Okay. Now, further defining IP addresses, they're divided into class A, B, C, D, and E, right? So when there were a lot fewer networks out there, right, IANA would assign IP addresses. And they said, you know what, we're running out of IP addresses. Let's form classes, right, so we can divide networks up. And so they did class A, class B. These are the notes here. So the first byte or octet is reserved for the network address, and the other 3 octets or bytes are for the host computer. Class B is a little different. It's the first 2 are for the network address, and the last 2 octets are for the host address. And you can see what it's doing. It's increasing or decreasing the number of hosts or the number of networks that a company can have, right? Class C has 3 octets for the network address and only the last octet for the host addresses. It would have fewer hosts. Classes D and E. D is used for multicast addressing. I wouldn't worry about it in this course. And class E is reserved for research addressing. Okay. And next we'll come back with subnetting of the addresses.